Okay, to explain this lab, we did it over this video, and it gives you fairly detailed instructions. You got to do it 5 times, once for each of these positions, 2, 4, 6, 8, and 10. And remember, it says for each trial, always start your stopwatch when the car reaches position 0. So starting is always going to be here. The time you enter in that table represents the amount of time it takes for the car to go from 0 to that corresponding position. So the times that you take are going to, they would typed in here, and this time here represents the amount of time it takes the car to go from 0 to 2. This time is the amount of time it takes to go from 0 to 4. So each of these should be a snapshot of where the stopwatch would be when the car is at that position, having started at position 0 every time. And so just as an example, we would start the thing. You see my stopwatch here. I'm going to start it here, and the car will get going, and as soon as it reaches the starting line, I'm going to hit the start button, and I'm going to stop it at 2, right? So somewhere around 3.71 is the time that I would have put in for this position 1 right here, right? And then I would reset. I would restart the video and do the same thing, except now I'm going to stop it at position 4. So we would start it right there. Let the timer run. Car moves, and we're going to stop it at position 4, right? So 7.45, and yours would be slightly different, but that would be the time I would put in this slot. You're going to do the same thing. You would do the same thing all the way down, stop the clock at position 6, 8, and 10, and you'll have these times in here. And then we talk about the speed right here. And the equation for speed, if you Googled it, that's totally fine, but something to do with distance, if I spell it right. Distance divided by time is what we should have done with that equation. Let me put some spaces in here so you can see that. Distance divided by time. And so that's the equation for speed. That's what our equation is going to be, and you'll learn that in the video in just a second. But we have the distances the car moves here. The car was it had gone a distance of 2 meters at this position, a distance of 4 meters at position 4, 6, 8, and 10. That was the distance. And these times in this column are the corresponding times that it took it to go that distance. And so when we use that equation, it really doesn't matter which of these positions we use. And you might have noticed when you're watching the video, the car is moving at a constant speed. So we could calculate the so let's look at the times we got. I think this one was 7.45. This was 3.6, I think is what it was. So if we do on the first one, distance divided by time would be 2 divided by 3.6. 2 divided by 3.6. If we do this on our handy dandy calculator here, 2 divided by 3.6 gives us something like that. 0.56 if we round that. We go to the next position. 4 was the distance, and it took the car 7.45 seconds to go there. So 4 divided by 7.45. Let's see what we get over here on our calculator. 4 divided by 7.45. 0.54. And if you do that for all of the positions, you should notice that it should be about the same. This is the speed that you should have come up with. But the whole point of this lab is to realize that we calculate speed by having 2 pieces of information. We have a distance and we have a time. If a cop pulls you over and says, "How fast were you going?" you would not tell him 40 miles. You not only need to know how far you're going, but how long it takes you to get there to calculate the speed. So speed is a rate of change of position, right? And if we had put different times in here, if the car was going faster, these numbers would stay exactly the same because the car is still going the same distance, but the times would be different, right? So if it only took, let's say it took the car 1.5 seconds to go that far. Well, to calculate the speed there, we would have done 2 divided by 1.5 instead, and it would have been 1.3 meters per second. That would have been the speed of the car. It would have been going faster. By the way, meters per second would be the correct unit here for these. All right, so that's just kind of a discussion of this speed lab. Understanding this equation and being able to calculate speed given distance and time was the main point of this lab.